Okay, let's go to a NUS file. So I'm going to go to OpenFID. I'm going to go to Johnson, and there is in there HNCACB file, one that Mark has used for a lot of his demos. So I'm going to open the SCR file. And again, just to save time in that, let's actually do just do openprocess.py. And you should have now a processing script. And let's just walk through the operation. So very simple. This is, I guess, not echo any echoes. So we just have sign bell, zero fill, FT, phasing, extract. I will say it's important in processing this data sets really to extract down to the minimum region in the directly detected dimension, because NUS processing of things that don't have signal in it is just a waste of your time. So it's important to sort of figure out a good region to extract. That's dimension 1. Dimension 2 and dimension 3 are basically standard processing. They may have negate pairs in them. The key thing here is that there is a dimension 2, 3. And that's the NUS processing. So what's going to happen is that we're going to process the first dimension, the directly detected dimension, and then we're going to load vectors if it's a 2D, or planes if it's a 3D, or cubes if it's a 4D, that are perpendicular to each data point in that direct dimension. And we're going to apply some NUS processing code to that, and then we're going to write those values back out. And it's just like I showed in that initial 1D with the IST or the NestA algorithm. We take that time domain signal and we replace the unmeasured values with some estimate that is better or worse depending on whatever algorithm we're using. So I've got 2 in here turned on, grins and NestA, that are both disabled. So we can just come to one of them. Well, actually, let's leave them disabled, and let's just hit the process button. So it's processed dimension 1, it processed dimension 2, it processed dimension 3. It's done in 3 seconds. So now we have a 2D processed spectrum. This is now a cube. And we have a new button that appeared here, Z. And if I go to Z center, I'm seeing the plane at the center, which is the default. If I go to Z full, I'm seeing all of the planes. So we see signal and we see a lot of streaks through the data set, and those presumably, to some extent, those are the artifacts from the NUS. And if you remember from my first 1D example, in theory, the intensity of the signals at their correct position is reduced, and that signal's been spread out into other locations. So let's go now to NestA, and let's just undisable it. Oops, I still have auto update turned on. So as soon as I changed that, it went away and did the processing. I turn that off so it doesn't do that. Okay. So that was, you know, the NUS processing is slower, but that, you know, that was 10 seconds. So like I say, we auto parallelize, and these nmrbox VMs have a lot of CPU cores on them. So if I go to script, you know, like I say, I guess the default I'm inserting is to run things 20 times in parallel. So each data point of the direct dimension that I load a, you know, a plane of data and process that, and I'm doing that 20 times in parallel simultaneously. So it does improve the performance somewhat. So that's kind of a pretty color. Actually, I kind of like that. But maybe we should hit auto scale. And let's go, we have lower and higher. Some people may think that I've got these backwards. So lower, rather than lowering the contour, really lowers the signals. So now you can see we'd have to look at this fairly carefully and go in and measure peak heights and stuff like that. But I think you can probably believe that we've gotten rid of a lot of those artifacts. And if we went in and carefully measured, we should find that the peaks are higher and the artifacts are lower. So that was nest A processing. We can just disable nest A and we can turn on what I call grins. And so we processed dimension 1. Now we're doing the 2, 3 planes, and now we're doing normal processing on 2 and 3. So a little bit faster. And looks pretty good as well. Like I say, you really have to go in and measure intensities and do slices and look at noise to really evaluate which one is working better. Just from this casual look, maybe there's more of a streak through from the grins. I should also say there are multiple options and parameters that you can play around to optimize. But basically, it's that simple to go. The only real difference from other processing of a regular fully sampled data set is to insert into this funny dim 2, 3. And if this was a 4D data set, you would have a dim 2, 3, 4 to insert one of these processing, misprocessing operations. If we come back to this, yes.
Bruce, so by a click of button, you can sort of comparatively do one or the other, for example, Nesta and this grins. So is there a way?
Yeah, it's not a good idea.
No, but it's pretty cool. But
well,
is there a way?
So here is I guess I don't have this in both. So in nest A, I guess I haven't put it in grins. There is this 0 at start.
Okay.
So basically, if 0 at start is turned on, it's basically everything that's not sampled is going to be set to 0. And normally, reading on the file, it would be set to 0. This goes in and sets 0. So you can do exactly what you described. You could actually do grins processing and then turn back on nest A and turn off the 0 at start. So the starting point of the nest A algorithm is going to be what was left by the grins algorithm. And I don't know if Jeff is still out there. He could weigh in and tell us if that's a crazy thing to do, but we've given you that capability. So now I've just done that. So now it's doing, you can imagine that some of these, the starting point for some of these algorithms, why start at 0? Why not start at some other value? I've put that in, but I haven't actually exhaustively played with it. But the point is, you can process in 10, a 3D like this in 10 seconds or so. So you actually can play around and see.
But my thing is at least, okay, let's say we start, so comparatively, I can compare the two results of the two different processing algorithms. Yes. So is there a way for us to save what we did with the grins?
Yes. So what you could do, I won't do it right here, but if we come back and go back to parameters in dimension 1, for data set, I can say, I'm going to call this data set nest A.
Okay.
And I'm going to come to operations, dim 2, 3, and I'm going to disable grins and make sure nest A is disabled. I'll turn back on that and hit process.
Okay.
So now I've processed, well, in 10 seconds, I will have processed nest A, and now let's disable nest A and let's enable grins. So you could actually be interacting with the GUI while processing is going on, because it basically spawns off the processing job into multiple processes. So that's happening sort of independent of the GUI. So now I've got grins enabled, and I can go back to dimension 1 parameters and call this grins. I can hit process. And let me get rid of my phasing. Let's see. Get rid of my phasing thing. And now I've got over all these icons, there's sort of funny little box icon here. If I click and drag that, I can drag that to any of the sort of landing spots here. And if I go here, it adds a second window there.
Oh, okay.
And if I come to data sets, let me remind myself, I'm going to go to the attributes panel and remind myself I'm showing grins here, and let's click this data set window here, and I can drag nest A over there.
Okay.
And now I've got them side by side. I could do full and that one, it's too high. I won't take the time to go through it, but the point is, there you go, boom. And you know, in one program, you can process different ways. You can save them under different names.
And compare them.
And you can go in and compare. You can select. One thing I like with the NUS processing is this is proton nitrogen dimension. So all the NUS action is happening on the nitrogen carbon dimension. So we can change the x-axis to show nitrogen, and that puts carbon on the y-axis.
Yeah. I
can actually go to spectra, sync axes, and now if I do anything in one, like expand, I'm happening in the other one. I can put up slices.
Okay.
And I can, now we're seeing multiple planes here. So if I put the cursor on top of the plane, I can either go to Z max, and now it's going to jump to the plane that has the maximum intensity on it. So now, boom, I'm at exactly the same plane in these two spectra. What I have to be careful about is making sure that the intensities levels are the same. So if I go to data sets,
yep,
this attributes panel applies to, let's get rid of this, to whatever window's active, and that's got a blue border around it. But if I change this to scene, now I see all the data sets that are in this window, and I can right click on level and say unify. So now I've set the contour level to be exactly the same in both of them.
Oh, that's awesome. Yeah.
And refresh. Okay, so we should have a poll, and you guys can tell me which one is better.
The left one.
Left one?
Yeah, that's your grins, is it?
That's grins. Yeah.
Yeah, there's a sync wiggle. Well, there's a kind of a wiggle on the Nesta, looks like.
Yeah,
sync
there is a little wiggle there. And that, you know, that comes back to a question I think you had asked of, you know, the whole question of doing apodization and, you know, how the apodization interacts and whether you're doing apodization inside the NUS algorithm or outside. But the gist is we've got you a nice little interface here to compare, and, you know, it could be the same algorithm, different parameters.
So that's pretty awesome.
We're working on adding some scoring functions from the NUS competition, so you can actually go in and quantitatively compare.
Yeah, that's pretty cool. Yeah, thank you. There are lots to explore, actually.
There's no reason you can't process. You know, you can process a file. You could go process in Smiles or IST and all the other ways that you learn about in the nmrbox workshops, and output those into NMR view or UCSF format and pull them in, so you can compare. You know,
right, side by side
here with processing done somewhere else. And I make no claims that we, you know, I make no claims that by any stretch, because I would say that we have not won the NUS. We only competed once, not win. So can't say that our algorithms are the best, but they're useful, fast, and easy to compare, and we keep looking at them. One little glitch that I haven't mentioned as we've been working through this, occasionally you might see, I go down and try to resize this window, and it's not resizing. And if I go up and right click on the border, you can see that the resize button is not active. That's a very weird low-level bug in the JavaX GUI toolkit that only shows up running in a virtual machine the way we're doing here on nmrbox. And it happens that normally these windows are resizable, but it happens that if some dialogues you open up, file choosers you will open up, once you've opened them up, it makes the window not resizable. And I'm trying to find all the places, you know, as workarounds to get that. Apparently there's one that I haven't got. I will say you can always open up a new window, file new window, and that new window is resizable, and I could go copy and paste Spectra into it. Igor Dickey has raised his hand. Igor, are you there?
Yeah, quick question. How is there a way to get rid of the second spectrum after we
Yes.
had it?
Yes. So as I said, whatever window you've clicked in is the active window, has a little blue border around it. And if you go to Spectra, delete Spectrum, it deletes the active spectrum. You cannot delete. You get down to one, you can't delete the last one. So you can add multiple spectra, and you could have added, we can add boom, more, and there are other ways to arrange them and lay them out. Okay, so let's just try to do a quick wrap up of processing. Because like I say, there are a lot of stuff we're going to cover today, and probably have burned through most of the morning session here without getting to a lot of other stuff, but I hope this has been useful. I'm just going to skip over the processing window here just to make sure other things that we might have missed. So parameters, like we mentioned a little bit, setting spectrometer frequency and sweep width, etc. Operation, where the operations appear. Options, there's only one thing which is real kind of new. I won't really talk about the script. You can see one thing I'll say, that you can actually go in and edit the script. You can go in and actually type in a command in the script. You know, if I could add, you know, another FT, kind of silly, and hit process, and it will process with that command. A bit of a glitch or feature is that as soon as you go back to the operations, come back to script, it rebuilds the script from all the operations, and so that whatever you change would be gone. I need to add a little checkbox to like make it so that it no longer auto updates. And finally, I didn't mention, so all the parameters, so-called vendor parameters, you want to see everything that was in a vendor parameter. So for Brooker, this is a compilation of all the things that are in the ACQ US, ACQ U2S, whatever's there. So if you want to see those raw parameters, that's there. So I think we'll wind up with processing and then spend just 15 more minutes on some other stuff and then take a little break. Let's see. So in theory, we can keep running things and opening new data sets. Sometimes I like, just especially in doing a demo, to make sure that things don't fail on me. I'll quit the program and restart if I really want to do some sort of switch things up. So I've quit, gone to nmrfx. As I said, if you run nmrfx from that longer nmrfx analyst, we would have seen the correct version number up here instead of 0. I'll try to fix that. Another useful thing to know, if you go to help, check version, that's going to go out to my web page and actually tell us what the latest version of the software is that I've built and released. And Box, we're not always up to date on Box with the latest version. And we'll say that there's nothing that stops you, from letting me know that you like a newer version of the Box, then I'll feed back to the Box people. And there's nothing that stops you from going and downloading and installing nmrfx yourself directly from our website into the Box, if you're desperate for a new feature that hasn't made it into the official VM release. So you can see what the latest version is And now let's go back and talk a little bit about peak picking, I think. So you can see there's a memory of data sets that we've opened and FIDs. The more you work through, these will build up, I think, called like 10 different things. So let's open up a Ubiquin Relax #1 SER that was in that summer workshop folder. So there's our ubiquitin spectra. Let's, just to make sure we have a good one, I'm going to go to open and open process works.py. Click process. And it looks like opening that process works.py triggers the freezing of the size. So that's one place I've got to go back and make a change in the code. Okay, so picking peaks. And let's also talk a little bit about the GUI here. I showed you once this data sets thing. If you click on it, it shows you all the open data sets, and you can just then drag data sets in here or into other windows. You can put multiple data sets on top of one, or add these grids of windows. Attributes, we saw again, should be familiar to nmrbox20 users. One thing that's different, we have this data selector available as a list of all the open data sets. Sometimes you use vec0, that's something left over from the processing. All the open data sets and all the ones that are selected display in this window, and you can use these arrows to move them back and forth. Attributes of data sets. If you have multiple data sets in a window, you'll have a whole table of values here. We'll come back to some of these when we actually look at some titration data, I think. So I'll come back to those later. The view, we can actually type in plot limits here. We can flip around the data set, so we can put the second dimension on the x-axis, flip it around that way. We have, I know Sparky users are familiar with adjusting the aspect ratio of a data set. So if I click aspect, now I actually calculate an aspect based on the frequencies, the proton and nitrogen dimensions, and I can change that aspect ratio. So it's a little funny because I can't resize this window. Let's actually put up another window so we can actually see that. Da, 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 da. New window, click data sets, drag in the data set, boom, grab attributes, come to aspect, I can change the aspect ratio. And now even as I resize the window, it's always going to keep the same ratio of the x-axis to the y-axis. And as I zoom in on the spectrum, it maintains a constant ratio. So peaks always retain their same shape. You can play around with what that shape is by changing the actual value of the aspect parameter. And if I click off, then basically the spectrum just fills the whole window. Come back to full. And don't forget, if you have questions about this, I don't always, this raise hand thing is a very subtle thing that pops up on my desktop, so I don't always see that. Let's peak pick. So peak picking, basically, if we put up the crosshairs around a region and click the pick button, boom, we've picked spectra. We can zoom in. The mouse cursor by default is in a crosshair mode, but we can come down here and change it to a selector mode. And then if we just click and drag the mouse, we zoom into that region. We can click on a peak. It's highlighted and we can move. So if we didn't like where the peak was picked, we can move it around. If we hold down, if we were not on the box, if we held down the selected peak and held down the Alt key, we could resize it. It turns out that something in the virtual window is capturing my Alt button, so I've made it on the box. You hold down a Control key and then you can resize. And if you don't have the Control key down, you can move the peak around. You can select multiple peaks if you hold down the Shift key as you drag. Now It's a little different color, orange, let go. Now we've shifted all those peaks and we can move multiple peaks. For both the resizing, as you start dragging, to see this, the border is a dashed line. If you let go while it's still dashed lines, nothing happens. So that if you accidentally start dragging, you decide you don't want to do it, just move back until it's dashed lines. We can do a variety of interactive changes of peak positions. I showed you that.
Bruce?
Yes.
So I have a question related with the peak picking. So let's say that you are doing the automatically peak picking.
Yes.
So that is fine. But let's say that some peak is not the correct position, and
Yes.
you want to add one peak. How you can say to the program, just go to the maximum peak of the center or something like that, without
yes.
doing the guess.
Yeah. So a couple things. One, like I say, you can click it. You can move a peak around.
Yeah.
You can actually make peaks, any selected peaks. If you right click and go to peak tweak selected, it automatically positions them to the maximum as long as they're overlapping the maximum. If a peak was not picked, and let me see, I know there's a peak in ubiquitin where there's some overlap.
Maybe in the side chains, just to see.
Well, let's just pretend peak 44 almost looks a little asymmetrical. Let's pretend that there were two peaks there. And we wanted, so the peak picker is very simple. It simply finds local maxima. So I can come in and just let the mouse hover in a place, and I can hit AA, and AA automatically picks a peak and finds the local maximum. So now actually I've got two peaks there, and I could reposition one of them. The other thing, I'll just move these away so it's a little easier to see. So that was just, I hit an AA on the keyboard. If I hit an AS, it picks exactly where the mouse is. So it doesn't do that local search. So had I had a peak here originally, I could have just come in and said, I wanted to add a peak exactly there. And then you could go in and do the resizing and move them around to position them. If you want to delete peaks, you just select them and hit, so I could highlight again with the shift key down, I could select multiple peaks and hit the delete key, and they're now deleted. We can fit peaks. Let me get this guy back close. So if I go to right click and say fit, now I've actually done a line shape fit to all the peaks. And that peak that was overlapping, you can see it will have done a line shape fit to, it detects that peaks are overlapping each other, and so it would have done a simultaneously fit of those two peaks to each other. If peaks are individually, let's actually see if this really works. Let's just select those two peaks, and then if I do peaks fit, it's just going to fit the peaks that are selected. So there, it's done a selection of those. We can see peaks in a different way. If I go to attributes and go to peaks, I can change this type field to be ellipse. And so now that's a little optimal. That's sort of a sense, the shape of the ellipse is based on the line width of the peak. It's a certain optimal fraction of the line width of the peak. So you can get a sense of really what the line width is like in there. So that's basic peak picking. What else is in this menu? So a fancier thing that I'm not going to show right now. Back in operations, there was this options command with a line shape catalog. If this is turned on, when you process, it generates a catalog of line shapes based on the appetization functions that you've used in the processing. And then if you actually do fit line shape pick fit, it will actually fit the peaks to those line shapes and actually redo the fits. And this is similar to a program called Infos. It'll actually do cycles of peak fitting. And eventually, in theory, if there were overlapping peaks, it should find those overlapping peaks automatically. A little trickier to show. And there's actually some new ideas to do things like that. For example, Colin Smith at Wesleyan talked to the ENC about a new method. It's similar to that comes up with line shapes in an analytical fashion to fit. So we're kind of we're doing a lot of work actually playing around with line shape fitting in complex overlap spectra. So I think you'll see more work happen in this area. Everything that picked ends up in this peak tool displayed up here. And so we can step through and see all the chemical shifts of each peak, its width. There's also a peak table. And again, nmrbox20 users, these may have different names, but will be familiar with a table of peaks that lets you see all the peaks and an individual peak inspector to look at details of each particular peak. Each spectrum has a toolbox down at the bottom. And so there's some peak tools here, for example, a peak navigator, and that lets us step through peak by peak. And so we can actually, this is a good way to systematically look at every single peak in the spectrum. By default, this value 10 here says it actually measures the average width of all the peaks in the spectrum, and then it zooms to be the window 10 times, or I change this to a different number, 5 times, whatever you want, the width. So this allows you to systematically step through every single peak in the spectrum and know that you've looked at it. If you find things that look like artifacts, I'll pretend this is an artifact. I can click this little box and I've now deleted that peak. It shows up in red as being deleted, but I can undelete it as well. And so that's a nice way to, like I say, early in a project, especially you're going to use these things for assignments, et cetera, where you really want to systematically make sure you've assessed every single peak and make sure that it looked good, there weren't overlapping peaks that were missed. So that, and there are a whole variety of tools that appear down below here. We hit that box and they're gone. I'll try to talk about more of them as our day goes on, but we probably won't get to nearly all of them. There's a measure bar here. If I put the cursor back in the crosshairs, I can see the specific position of the peak in points in hertz and the difference between the two cursors in hertz. We can go in and do things like measure the signal to noise in a region of the spectrum and measure noise values. So that's measure tool. There's a so-called analyzer bar, also lets you measure, go in, put around a region, click analyze. And so now I've got the minimum and maximum value in this region. I can put it over a noise region, and now I've set the data set noise value to be that. And if I go over over actual peak and say analyze, now I've measured the maximum intensity of that position and divide that by the noise. You get a signal noise measure for that particular peak.
Bruce?
Yeah.
So just a very basic question. So the black and red cursor you get, is this right and left? Left and right?
That's a good question. Sorry, there's a million things that I'm sort of skipping over. So by default, let me just expand. By default, when the program starts up, if you click with a mouse button, you're going to get the black crosshair. Okay. If you click a distance near that crosshair, you'll move it. If you click some distance away, you'll get a red crosshair. I'm doing that both with my left mouse button.
Okay.
As soon as you click anywhere with the middle mouse button, if you have one, the software in some teleological sense says, oh, you've got a 3-button mouse. From that point on, the left crosshair moves no matter where you click it, moves the black crosshair, and the middle button moves the red crosshair.
Oh.
So that allows you basically to work with a single, with just a trackpad or a single button mouse. And if you have a 3-button mouse, you can toggle back and forth. I haven't, there are a whole series which should be documented of shortcuts. So there is a shortcut, C1, puts you in single button crosshair. I'm just typing these keys, you don't see anything. CS would toggle me from the crosshair to the selector cursor, and CC would put me back in the crosshair cursor. C3 puts you in 3-button mouse mode, C1, 1-button mouse mode. So you can toggle between them all. Other useful things, VF, view full, VE, view expand, VI, zoom in, zoom out. A new one, which I'm not sure if I got in the documentation, VP, to pop, view pop. So it pops out that view into a whole separate window.
Oh, that's cool.
So these should be, should pretty much all be documented, a variety of different options. So that's just like the peak picking that I showed with the AA and AS commands. There's a whole series. For years, nmrbox20 had key bindings. Spark users always, he told me they wanted more key bindings, and the way to do that was with multiple key bindings. So we've switched to a lot of multiple key press type things. And we're just starting to add the ability where you can actually add your own bindings to bind a particular operation to a particular key presses. So we're at 12:03. Let's just give a pause for people to raise their hands or anything else they want to do. Chime in if they have anything that we've covered in the morning session that they didn't see. I'm trying to find, there we are. I'm trying to find the.
Bruce?
Yeah, yes.
I have a quickly question related with peak picking. So
Yes.
What is the logic that you use in this NMR view viewer, let's say, to do the peak picking in the third dimension, let's say in some NOSI or some carbon edited experiment?
Yeah, in terms of, so 3D is exactly peak pick. So in fact, we should just be able to go, let's open a new window. Let's go to File, Recent Data Sets, and scroll back and find my GRINS data set. Let's display full. Let's get the lower down. As it's drawing it, you can change any of these things. Any of the functions that change the view will interrupt the drawing, so that I can just, as it's redrawing, I can sort of update the view. And basically, I just put the crosshairs. If you don't put the crosshairs, it's gonna, and hit pick, it'll pick the entire window, but sometimes there's some noise or artifacts you want to leave out, so then you put the crosshair around just a region. In fact, let me just expand on that. If I put the crosshairs around this region, hit pick, so it's picked the 3D data set, and it's picked just in the crosshairs. I could then put the crosshairs over another region and pick, and if those regions are not overlapping, it's gonna append onto the peak list. If they were overlapping and I hit pick, it's just gonna basically restart and pick just that region. So it allows you to sort of go around and grab individual regions picked. But now these peaks are all, and I'm not sure if
there is a way to do it by 2D filtering, let's say.
I do not at the moment have to. I think nmrbox20 had 2D filtered. If we get a chance to give you a show of our runabout assignment tool, it has a filtering mode in it that sort of after the fact allows you to filter data sets. But I should add back the whole idea, and like I say, nmrbox20 had it, to be able to say, pick your HSQC and then only pick in the 3D spectrum peaks that are overlapping those. So that's not in here yet. But
okay, thanks.
we have precedent for doing that in our other software, so it should come back. But otherwise, the peak picking is basically the same as 2D. You just show a whole region. It is a little different if I show a single plane in a 3D spectrum. If I show multiple planes and pick it, it picks them as 3D peaks. If I show a single plane, it assumes that we just are, this is like a pseudo 3D and we're gonna pick 2D peaks on that particular plane. So that's a distinction. When we'll look at some relaxation data after our break, where that'll be important. Right, so I'm gonna take a break. Let's say we'll come back at 12:40, let's say 12:50, because we ran a little bit over. I'm gonna say anybody that, there should be a chat window up, and I assume that's effective. If anybody during this break, if there's anything they want me to come back and show, or if there's anything that really like I'm going to get some other things, including some relaxation stuff, a little overview of our assignment stuff. I was going to try to show you some 1D processing. So if anybody really wants to see analyzing a 1D spectrum and fitting things, the idea is, why don't you stick things in this chat and say, please explain this, or please show this, and then we'll try to concentrate afterwards. So I see a hand raised.
Hey, Bruce.
Yeah.
So are you going to discuss the kinetics fitting day today? Will you have time for that?
I will show you some. So we're gonna do some relaxation T1, T2 measurements. If that's what you're talking about, I'd hope to do a quick overview of titration curves.
Titration curve, sorry, that's what I meant.
So let's do that as the very first thing when I come back, just to show you that. And then we'll see where we get. Well, like I say, throw into the chat here, just list things people want to see. I know we can't cover everything, but it'll also tell me if we want to do a follow-up these office hours, whatever, what things we got to do for a follow-up one. So let's take a little break and be back 12:45, 12:50, something around there. So if I will probably be here earlier. So if people come back a little bit, earlier, just want to see some hands-on stuff, I have some questions.
Thank you,
Thanks,
Bruce.
Bruce. That was wonderful.
Incredible. I cannot believe how many features you pack into your software interface and just the intuitive feel that you can give us for working with NMR data sets. This is really impressive.
We squeeze it in, so I hope people like what they see and go home and use it. That's the bottom line.
Yeah.
So great, everybody. Let's see you back in a little bit. Like I say, I'll come back a little bit early, so I'll be here if people have questions, and if there are things you want to see, throw it into the chat.